Okay, and we're rolling, guys. Okay, first I gotta switch over the camera. Everybody has a pencil, right?
Yes, ma'am.
Thank you for the manners. Thank you for the manners. Okay, everybody is sitting kind of, sort of near tiles, or we'll be ready to rumble to sit near tiles if we need to. Okay, if not, just go ahead and kind of shimmy over. Buy some tiles. You won't need them right now, but you're gonna need them in a second. Okay, does that make sense? Kind of. Okay, so I'm gonna start with this little activating activity up here. I'm gonna put this on the board. If you're up at the front, kind of scooch back so that you can see. Okay. Okay. All right. So on the board we have a few things here. I don't know everything. It just says yes and no. So I have a garden. Yes. I have swimming pool lanes. Gosh, that sounds so amazing. I have no. I have this cool little hot tub situation. Yes.
Yeah.
This rug. No.
No.
The middle. It's,
And what about
it's
the
pointing. A scale is a no. A door is a yes. This is like a riddle. A pen, maybe you can put like some pigs in there, right? A pig pen, maybe. I don't know. Is a yes. A clock is a no. Cool tile. Wow, that's really pretty. Is a no. This picture frame is a yes. Huh. Turn and talk to a neighbor. What do you think this is about? What similarities do you notice? Okay. What similarities do you guys notice in this side? Aaron, what do you notice on this side?
I noticed on the side that there's like pool, but on the north side there's
Pool. So there's pools on this side. All right, cool. Oh, there's pools on both sides. Here, let's do it like this. Same. And I'll say, can I just say dip? Y'all are good with that, right? Okay. So they're the same because they both have pools. So that's what Aaron said. All right. What else do we got? Mia?
I think on the left side they're all furniture.
They're all furniture? Okay, so Mia says she noticed they're the same because they're all furniture. You guys can also, you can start saying how they're different too. Okay, Zayden, what do you notice? How they're similar or different? Which one are you going to pick?
They're different because the yes has all squares, but no has like a clock, which is different, and the lane.
Okay, so he's noticing on this side that they're different shapes. Is that what you're saying, buddy? Okay. But Zayden says on this side that you notice that they're all squares. Okay. Do they agree? Okay, I have 4, 5, 6, 7 people that agree. Okay, Francis?
Like there's a door on this side, but no door on this side.
Okay, we have a door on one side,
No door.
and then we have no door. So in that living room scene, where'd the door go? Okay, anything else? Josiah?
We're going diagonal.
You're going diagonal, what do you mean?
I mean, like all of them are going diagonal.
Oh, like the way they placed them?
Mm-hmm.
Okay, so the placement's the same? Cool. So here's what we've got so far. Aaron and Mia have noticed like what is in the picture. So Aaron's like, hey, there's a lot of pools. And Mia's like, and there's a lot of furniture. Okay, so we're doing something with furniture, maybe pool stuff. What do those two things have in common, maybe? Okay, we've also noticed that there's lots of square things. Can we also say rectangles too, Francis? Or yeah, with squares and rectangles. I noticed that too. That was a good one. Anybody agreeing with that? That they're seeing a lot of squares and rectangles? Now, Zayden said, hey, on this side though, I don't see squares and rectangles. He pointed out this clock, which is like a circle-ish situation, right? Okay, and then who was it that said door? No door, I forget. That was Francis? Okay, and I noticed, hey, just kind of piggybacking on what you were saying earlier, a door is what shape? a rectangle and no door. That's obviously not a rectangle, which is kind of going with what Zayden's saying about different shapes. Okay, here's the question. I wonder, what do these pictures, these similarities and differences, specifically focusing on the yes box, what math concept do you think we're going to be learning about today? We've learned about, it says, we've just pointed out we're going to be learning about a lot of squares and rectangles. What math concept? We've actually been talking about it earlier this year.
Geometry.
Geometry? Yes, this is a focus of geometry. Gold star. Geometry. Now it's not just geometry. There's one thing in geometry. It starts with the letter P. Starts with the letter P from geometry. Colin, do you know? Yes, we're going to be focusing today on perimeter. Okay, perimeter, which is a form of measurement that we're going to be doing today. So that's what these mixed tiles are in front of you. We've been working on measurement, and we've been working with the mixed tiles on measurement stuff. Today, you guys are going to have a dinner party later, and I want you to design some tables for me. So that's why that's out, all right? Good job with that little activity. Now, does everybody here have a sticky note?
Yes, ma'am.
Okay, thank you for the manners. Okay, so I'm going to just show this little situation right here. Let's see. You can see this, okay? Okay. So, we're going to learn about measurement and how to measure stuff to the nearest half inch and nearest quarter inch, okay? We've been learning also how to measure things in weight. We've been learning how to measure them in ounces and in pounds, remember? And then we've also been learning how to measure things in liquid containers. Is everybody tracking so far? Mm-hmm. Okay. Today we're going to be learning how to measure things through perimeter. You say perimeter.
Perimeter.
Okay. Perimeter of, there's another word I'm going to tell you, polygon. You say polygon.
Polygon.
A polygon is just something with four, yeah, four, yes. Okay, four sides. And I'm going to be showing you today, not just with like random shapes, but we're going to be using real world problems to measure out perimeter, okay? Measuring perimeter means that we're going to be finding the outside total length of something, all of the side lengths, okay? All the way to the outside. Okay, so I'm going to show you, I have a problem for y'all. I printed out. Okay. Here's the problem. It says Ashley painted a 5-inch by 7-inch, oopsies, 5-inch by 7-inch rectangular picture for her mom's birthday. She wants to frame her mother's picture with wood she purchased in the store. What is the total length of wood she would need to make a frame for the picture? Okay? So how many times we read word problems?
2.
Yeah. So Ashley painted a 5-inch by 7-inch rectangular picture. There's a key word right there, rectangle, for her mom's birthday, and she wants to give her a picture frame. She wants to frame this picture, okay? So the first thing I want to know is, what is this problem asking me to do? I know that Ashley, she painted a really pretty picture, and what was the measurement of it? How big was it?
5 by 7.
Josiah? 5 by 7. Bingo. And if I'm picturing this, what shape am I seeing in my mind? A square, a circle, a rectangle? Just shout it out.
Rectangle.
A rectangle. It tells us it's a rectangle. So, using what I learned from finding like area of rectangles, I know the dimensions of a 5-inch by 7-inch means that my picture frame is in a rectangle, and it's 5 inches by 7 inches. So right here I have, is this okay? 1, 2, 3, 4, 5. Okay? I'm literally going to build a model of what this frame looks like. And you're going to have an opportunity in just 1 second to also build some models that you'll see in a second. 1, 2, 3, 4, 5, 6, 7. Okay, and now I'm just going to fill in. I have to make sure that everyone has a table here. So Ashley needs to make a frame for this picture that I'm making for her mom. So frames go inside of a picture, outside of a picture, around a picture. How do frames go? Around a picture. Frames go around a picture. So I know that I need to know the distance around this picture that I'm making right now with colored tiles. to figure out how big my frame needs to be, right? Okay, so I'm almost done here. I'm gonna put it into speedy mode. Okay.
That is kind of beautiful.
It is beautiful, thank you. I'm gonna give it to my mom later, okay? Okay, here we go. So, pop quiz. When we wanna know the distance around a shape of something, that's called something that starts with the letter P. What word is that? Perimeter. When something goes around the shape of something, it's called the what?
Perimeter.
The perimeter of something. Very good, very good, very good. Okay, so I need to know the dimensions of this picture. So I know right here on this side, how many inches is it? 1, 2, 3, 4, 5. Good job. 5 inches. Perfect. Okay, and I know it's a 5" by a 7". So what is this top part here?
7.
7. So this is 7 inches. Instead of writing the whole inches out, I'm just gonna put 7 IN. Okay? Now what about on this side? Is it the same as like this side right here?
Yeah.
It for sure is. So 5 inches here. Okay? Boom. Can y'all see that one? Yes, you can. Okay. And then I have right here 7 inches here. Okay? So my frame, I don't know the size of it yet, but I do know the dimensions of my picture. And it goes, whoops, I'm going to scoot this up a little so you can see it. 7 inches, 7 inches, 5 inches, 5 inches. Oh my gosh. So like the distances across from each other are the what?
Perimeter?
Are the same.
Same.
You guys notice that too? Okay, so it's helpful labeling the size whenever we're trying to figure out the distance around something. Is everything okay back there? Okay. All right. So I need to figure out how much wood that Ashley needs to make a frame, so I have to find the perimeter of this picture. Remember that perimeter is the distance, what, around to something? Inside, outside, or around? Around. Okay. So one thing I can do this is by counting, literally counting the length. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Ooh, 21. Okay. Or I could say, wait, did I do this right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yeah. Or I can see that there are edges around the side lengths here. So a quicker way I could do this is I could just, let's see, if I just do it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So y'all, I made a boo-boo earlier. I only counted 21 the first time because I only counted the tiles. But when I'm doing perimeter, I have to count the edges. So do you notice that this blue tile, it's the same tile, but I had to count it twice because I have one edge here and one edge here. Does that make sense? Yeah. Why didn't I count the inside of the tile? Is that around the picture?
No, it's inside.
That's inside the picture, right? Okay. Now a quicker way that I could add up all the sides is I could just say 5 plus 5 is what? 10.
Plus 14.
Plus another one, 10 plus 7 is?
17.
17 plus another 7 is 24. I could just add all this together and I would still get 24. Which way do you think is easier? Adding up all the sides or counting it? Probably adding up all the sides. So when we're trying to find perimeters of shapes, whether they are rectangles, squares, rhombuses, triangles, hexagons, name the shape, we always add up everything to find the perimeter. Does that make sense?
Yes,
ma'am.
Okay, so perimeter is the area, not the area, it's the distance around a shape, and to do that, what do? Multiply, divide, subtract, or add? Add, okay. So, here is your next problem that I want you to solve. Okay. Okay, with the tiles in front of you, I want you to solve this with some buddies. It says, Ashley's brother, Josh, wants to frame his picture for his mom. That's 3 inches by 4 inches. What is the total length of wood he would need to make a frame for his picture? So go ahead with some partners. I want you to design your frame. Your frame's gonna be 3 inches by 4 inches. I've got one extra basket.
This will be small.
Here you go, buddy. 3 inches by 4 inches. We're designing our frame. Alright, you guys have 3 so far. It's okay, Josiah, you can work right now. Alright, let's do 30 more seconds. Build that frame. 30 seconds. Build your frame. Build your frame.
Let me do. Oh, I know. 3 plus 3.
Yeah.
Plus 3 plus
3 by 4. 3 by 4. Double count yourself. Make sure it's 3 by 4.
3 by 4.
Yep. That's right, Brooklyn. That's smart. You're using your board as well. Okay, so you got your 4 across. Well, how far down you want to go? Kenzie, you guys see 1, 2, 3, 4, 5 across. There you go. All right, once you have your frame built, go ahead and count the perimeter. I see 4 by 4 across, right? You follow there, 1, 2, 3, 4, and 1, 2, 3, 4. The problem's saying 3 by 4, so how can you change this to make it 3 by 4?
What's 3? No, 4 plus 4.
There you go. Okay,
Plus 4 is 8.
now we're trying to find the perimeter. What?
Plus 3. Plus
Yeah, yes, yes, you need to fill it in. What do we think? Josiah, wait, if you're filling out the area around to find the perimeter, do you really need to fill it in? I think you're on something. Do you have the answer?
Yeah.
Okay, so we're trying to find the perimeter of our frame. So if you haven't finished yet, but there's someone near you that's finished their frame. The frames look beautiful, by the way. You can go ahead and kind of look on theirs, okay? And we're counting up the perimeter of our frames.
3 by 4. That's a 3 by 3.
I noticed some of you guys are counting them one by one. If you're doing that, make sure you're counting the edges. So one tile, if it's a corner piece, it's gonna have 2 that you're counting, right? All right, I want you to show me thumbs up when you have the answer. What the perimeter of Josh's frame. Okay. Okay, let's see. Josiah, what was the perimeter that you got? 14, okay. So Josiah says 14. Josiah, how did you get 14?
Because 4 plus 4 equals 8. On top, 4 plus 4, and then 11. Then 8 plus 3.
Wait, okay, so I had 4 plus 4, so you said your 2 sides. But then where did you get the other ones? You said 3 plus 3? 4 plus 4 plus 3 plus 3. So 4 plus 4 is 8, and 3 plus 3 is 6,
Plus 14.
and 8 plus 6 is 14,
Yeah, I agree.
okay? Anybody else do it differently? Anybody else do it differently? Did anybody count by ones and just go 1, 2, 3, 4, all the way around? Good. If you did that, you have to be careful. If you got 12, did anybody here get 12? If you got 12, here's what happened. When you were counting your tiles, you did what I did the first time. You counted each tile individually, right? And instead, remember, you have to count the edges. So for example, if this is the tile, right? Pretend like this is my tiles. I have 4 tiles here. I have to count them 1, 2, 3, 4. It's the same tile. So Severe, did that make sense? If you count it that way, double check your work. did that. Now, did you get 14? Yay! Okay, so everyone should have gotten 14 with that. Awesome, awesome, awesome. Okay, now I'm going to have you guys listen to a story about a family who loves spaghetti. So here we go. They love spaghetti. So let me show you. This book is called Spaghetti and Meatballs for All. Okay. So y'all can sit quietly, put your eyes up at the board. This is going to get us into our next activity.
Hey, third graders. Today I'm going to read Spaghetti and Meatballs for All, a mathematical story. Written by Marilyn Burns, illustrated by Debbie Tilley, and read by me, Mrs. Martin. One fine day, Mrs. Comfort was busy tending the lettuce patch in her garden. You know, it's been a long time since we've seen the family, she said to her husband. You're right, answered Mr. Comfort. He was stretched out on a bench doing what he liked best in a vegetable garden, reading a cookbook. Maybe it's time for a family reunion, Mrs. Comfort said. A wonderful idea, Mr. Comfort agreed. Let's see. Menus, dinner for 2, serves 4 to 6, banquets. How many people would we be having? He asked. The Comforts called their children. They called their parents. Mrs. Comfort called her brother. Mr. Comfort called the next-door neighbors, who were almost like family.
So
Everyone could come.
having a dinner party.
That's 32 people all together, including us,
32 people.
Mr. Comfort said. What could possibly fit in our oven and still feed 32 people? He wondered out loud. Why not make your favorite
What are they going to make?
spaghetti and meatballs? Asked Mrs. Comfort. Good thinking, said Mr. Comfort. Now, what about renting some tables and chairs? Asked Mrs. Comfort. She got out the phone book. 2 weeks later, the big day arrived. Mr. Comfort got up very early and spent all morning cooking. He baked 16 loaves of garlic bread and made 8 pounds of fresh pasta. He simmered 8 quarts of spaghetti sauce and rolled 96 meatballs.
Whoa.
Mrs. Comfort picked all her ripe tomatoes, cucumbers, and lettuce for salad. While Mrs. Comfort waited for the tables and chairs she had rented, she drew a seating plan. Then she got out the dishes and the silverware and the glasses and the tablecloths and vases. But when the rental company arrived, they were 1 chair short. Don't worry, said Mr. Comfort. You'll think of something. Mrs. Comfort found a folding chair. Now the tables were ready. Each had 4 place settings, 4 chairs, and a vase with lovely cut flowers. Mr. Comfort came out of the kitchen, balancing 8 plates of celery and olives, 1 for each table. Just after noon, the Comfort's daughter and her husband arrived with their 2 children. Welcome, said Mrs. Comfort. Come sit, said Mr. Comfort. Let's push 2 tables together so you can sit with us, suggested the Comfort's daughter. But there won't be room, Mrs. Comfort said. But there is, said Mr. Comfort.
So look, guys, look what happened. They had all these tables out, so they had chairs. When they pushed them together, what happened to these 2 seats?
Oh, they don't have.
Oh, are they going to have enough room for everybody to sit down now?
There's plenty of room and plenty of garlic bread. Everyone was just about to sit down when a car pulled into the driveway. Mrs. Comfort's brother and his wife, their daughter, her husband, and their twin sons all spilled out. Welcome, said Mr. Comfort. Sit down, sit down. Oh, let's push 2 more tables so we can all sit together, said Mrs. Comfort's brother's wife. The Comfort's daughter and her husband got up to help. But that won't work, said Mrs. Comfort. You're so right, Mr. Comfort said. We'll have to push 2 more tables together. But that won't work either, said Mrs. Comfort. You're right, said Mrs. Comfort's brother's wife. Make way, shouted Mrs. Comfort's brother and the Comfort's son-in-law. They each carried over a table and put them side by side. You don't understand, Mrs. Comfort sighed. My plan was... But no one heard her. Everyone was too busy.
Oh no, they got rid of even more seats.
Save some of that garlic bread for me, a new arrival called. Me too, me too, me too, 3 more voices piped in. Well, look who's here, said Mrs. Comfort's brother's daughter's husband. It was the Comfort's next-door neighbors with their daughter and son. Hello, hello, said Mr. Comfort. So glad to see you. Have a seat while I get more garlic bread. But there's no place for them to sit, said Mrs. Comfort. Don't worry, said Mrs. Comfort's brother's wife. We'll just divide these tables into 2 groups of 4. Go ahead, Mrs. Comfort said, but I'm telling you when... You fret too much, said Mr. Comfort. Bread, anyone?
Okay, so what's happening, we're gonna kind of skip through this, but what's happening is that more people are coming and they're changing the way that the tables are. And so they're getting less and less and less seats, okay? So we're gonna see if we can solve this problem for them, okay? So, I'm gonna flash a problem on the board, okay? And we're gonna see if we can help the Comfort family figure out how many are gonna sit for spaghetti. But here are the rules, okay? You're gonna make some table arrangements. It's not gonna be, they had 32 guests in the book. I'm gonna give you guys a number of guests, and you're gonna have to figure out the seating arrangements, how many different seating arrangements you can make, okay? Here are the rules. You cannot make seating arrangements where just the vertices are touching. Does everybody see this? You are not allowed to do this. You can do this where sides are touching. This counts, okay? And this counts, but you cannot make it where vertices are touching, okay? So that doesn't count. All right, so I want to see how many people can sit at each table. Here's the very first question that I have, and you're going to be working together with your partners to collaborate on this, okay? So the first problem that I have for you, okay. Mr. and Mrs. Comfort have now decided that 12 people should sit at one large rectangular table. What are the possible table arrangements she could create so that all 12 people could sit? I want you with your tiles and your partners to find all the possible rectangular tables of different sizes that can seat 12 people. So you're making it to fit 12 people. One big rectangular table. How many different ways can you do it? Ready, go. Rectangle.
So I'm thinking since half of 12 is 6, right? 12. We can make like this. Because we finished already.
Your partner was
6 equals 12.
all our partners, okay, then all of you guys are working together. And so far we started, and no one's sharing ideas out. You guys are all individually working. So I want one person to be the group leader. All right, Kanaya, why don't you do it first, and then Sarah, you're here giving feedback. Let's see what I should be doing, okay? Okay, how many does that fit? So on your paper, I gave you your note paper. I want you to write how many combos you could think for this first one. 12. Okay, so what is your perimeter? 12. 1 by what?
1 by jump and
Nice. Okay, so I have one group that found one way.
I got 6 plus 6 because
Oh, but look, I want one large rectangle table. One large rectangle table.
So let's pretend like these are, or we could have 4, or we could have 20.
So what have y'all done so far?
No, we could have 4 people in each piece.
Okay, so you're trying to find the perimeter of 12? Okay, so what's your perimeter so far?
In each table, like 4 on
So you're trying to find 12, so you're going to kind of build it as you go, and then kind of at the very end, is that what you're doing? Okay.
Done.
Do you think that way is going to be easier, or to try to find the perimeter and count it as you go? Okay, let's see how many you have so far, and see what we need to do.
Alright, 12 people. 1, 2, 3, 4, 7, 8.
Wait, so that's where you count this twice. 1, 2.
No, it doesn't matter about these two.
Yeah, remember, we're trying to find it after 12. So a person can sit there, and a person can sit there, right?
There's only chairs on these sides. They have to be on the sides too.
Remember, it has to be one large table, so it has to be a rectangle. So the table
Wait, I got
has to be like together. Does that make sense?
Wait. No, because oh my mom. Done.
Alright, can you convince me your table fits 12 people, Josiah?
Yeah.
Convince me.
So 6 plus 6 equals 12, right?
Right.
Half of 12 is 6. So we put 6 people on the top, and we put 6 people on the bottom, so it all equals 12.
Does that, you agree? Is that how you do it? Very nice, very nice. All right, Brooklyn, convince me that your table fits 12.
Alright, so this is the table of 12. So this is our
Fabulous.
second grade.
How are we doing, girls? Convince me. Does your table fit 12? Well, is perimeter addition or multiplication? But remember, don't focus on perimeter. Can you count where there could be 12 people that sit at that big table? So where the chairs gonna go?
You just wait.
Convince me.
With 8 plus 8. These two sides don't have seats. No, it's not.
Convince me that that's
8 is not.
Oh, he says the edges don't have
The edges count. Guys, don't worry so much about perimeter. I want you to think about where the chairs are gonna go. Where are the chairs gonna go? Okay. I think most of you guys have figured out a seating chart of 12. Okay? Here's what I want now. Pause. Okay. I'm about to rotate some people around. Pause, pause. 2 up.
3, 4.
I'm about to rotate. 2 up.
3, 4.
Eyes up here. Nothing in your hands. I'm about to rotate some people around. It is okay if you have to stand up and leave all your stuff. At the very end, you can come back and get it, okay? If you are one of the ones moving, be respectful of other people's stuff. Please don't step on it, okay? If I have to put you with a new partner that you've never worked with before, what you're gonna say is, okay, and go. You're not gonna say yes, and you're not gonna say no. You're just gonna say, okay, and leave your poker face on. Because right now we're just doing math, and we're trying to plan a dinner party, okay? All right, I want Bryce to go sit next to Brooklyn, okay, and you guys are partners. I want Mia to go be with Francis and Colin. I want Taylor, turn around and be with these fellows right here, all right? And then let me get Sahira and Natasha, you work together, and Kanaya and Kenzie, you guys work together, okay? All right, does everybody have a crew? Aaron, you're doing good working with Brooklyn, okay?
What? I thought you said.
Well, yeah, you guys, you can stay with them, okay? Here we go. Thank y'all for doing that so great. Ready? New problem. So now Mrs. Comfort decided that 18 people are going to sit at one large rectangular table, right, Josiah? One large table, not 2. So how many table arrangements did she create so that all 18 people could sit down? Okay, 18 people now. So we've added some. So Taylor's going to be 12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 20. No, wait.
17, 18.
Too much, I think.
No, wait, what about these sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.